In this lesson, we are going to solve the question I have on the screen. The question says that the figure shows a particle of mass m suspended by a light string of length L from a fixed point O and describing a horizontal circle with constant speed v meters per second. If the angle theta is 30 degrees and L is 1 meters, determine the speed v. So that's the question. So you have to determine the speed of the particle as it is being caused to move in a circular path. So let's look at how you are going to do this. So before we solve this question, I'm going to take you through some few analysis so that you will understand the concept of this question. So let's say I have a particle. I have a particle moving in a circular path, okay, from a fixed point. Let's say I have a center here. What is happening is that this particle here is moving in a circular path, okay, so it will be moving, let's say it will be somewhere here after some time, it will be somewhere here after some time. So you see that the ball still remains in the circular path. Why doesn't it change its position, okay, but still moves in the circular path? The ball is able to continue its motion in the circular path as a result of a force which is holding it in position, okay, as a result of a force which is holding it in position. This force is known as the centripetal force, okay. So this force will cause the particle to continue its motion in the circular path, so that it will not change its position, okay. So it will cause the particle to move in the circular path, okay. So let's assume that in a situation whereby the force is no more there, okay, the force is no more there. Let's say if this ball was held by a string and then the string has been cut, you see that the ball will move in this direction, okay. The ball will move in this direction. So this direction will be perpendicular to the force, okay. This direction here will be perpendicular to the force, and then since it is moving in this direction, that will be the direction of its speed, okay. So when the rope is cut, the ball is going to move in this direction perpendicular to the force, okay. So it will cause the body to cause the object or the particle to speed up in this direction. If you take a close look at this in real life, when let's say you have a ball attached to a string and then you are moving it in a circular path, okay, and the string gets cut, okay, you see that the ball will move in a path which is tangential to the circular path, okay. It will move in a direction which is tangential to the circular path, and then that direction will be the direction of its velocity, okay. That direction will be the direction of its velocity. So in this circular motion, okay, the direction of the velocity of the particle will be perpendicular to the force, or you will see that it is tangential to the circular path, okay. So this velocity here is known as the tangential velocity, okay. So v is the tangential velocity, and then the force which is causing the particle to maintain its circular path is known as the centripetal force, okay. We know that force equals mass times acceleration, but in this case we are dealing with centripetal force. So that will be centripetal force will be equal to mass times centripetal acceleration, and the formula for centripetal acceleration is given as AC equals v squared over r, okay, where r here is the radius of curvature and then v here is the velocity of the particle. So therefore, you can see that the centripetal force will be equal to what? Mass times what? Centripetal acceleration, which is what? V squared over R. So this will be the centripetal force. Okay, so with this knowledge, let's go ahead and then solve the question. Okay, let's take note of this formula here. So I'm going to free up some space so that we solve the question. Okay, so now let's continue with the question. So for the question, you have to determine the velocity, okay, of the particle in the circular motion. Okay, so what I'll do is that I'm going to draw a free body diagram for this particle. Okay, so let's look at that. So I have the particle here, and then I will draw the forces that are acting on it. Okay, so the particle has weight, and then there will be a force due to the string. Okay, so that force is tension. Okay, and then this tension force here will be causing the ball or the particle to move in a circular path. Okay, and then we know that since the force is directed towards the center, then acceleration will also be directed towards the center. But looking at this tension force here, it has an angle. Okay, it is at a certain angle. So let's look at that. So if I draw a vertical line here, okay, let's go back to the figure. If I draw a line here, you see that we have an alternating angle here. Okay, so theta here will be the same as what the theta here. Okay, so in that case, this angle here will be what? Theta. And the question that is given to what? 30 degrees. Okay, so that will be the angle that the tension force is making with the vertical. So now, we know that this tension force here is at an angle, so it is going to have x and then y components, right? It will have an x and then y component. So let me indicate that. Yeah. So let's say this will be the x component, and then this will be the y component. Okay. Okay, so now this is what we have now. So this is my free body diagram. Okay, and then we know that the question says that the particle is describing a horizontal circular path. Okay, which means that its motion is in the horizontal direction. Okay, it is moving in a horizontal circular path. So that means that the acceleration will be in the horizontal direction. So I'm going to have the acceleration here, and then we know centripetal acceleration to be equal to what? V squared over R. So this will be the direction of what? The acceleration, because the particle is moving in a horizontal circular path. Okay, so that will be the direction of what? The acceleration. It will be in the direction of what? The force. Okay, so now all you have to do is to know the x and the y component of the tension force. Okay, so let's look at how you are going to do this. So let's say I have this triangle here, I have theta here. Okay, then this is the y part, this is the x, right? So when I take cosine of the angle theta, cosine of theta will be equal to what? The adjacent, right, over hypotenuse. So let's make the hypotenuse t. So that will be what? Y over t. So in that case, you are going to have y to be equal to what? T cosine of what? Theta. And then the x will be equal to what? T sine of what? Theta. So this will be the x and y component of what? The tension force. So that's what we want to know. Okay, so let me write this here. So for the tension force, I write Tx to be T sine theta, and then Ty to be T cos theta. Okay, so now we know the components of the tension force. Okay, so we want to find the velocity, okay, which is this velocity here. Let's look at how you are going to get the value for the velocity. Okay, so now all you have to do is to write down the equations for the summation of what? Forces. Okay, so let's go ahead and then do this. Okay, so now when you consider the forces that are acting on the particle, you see that we have some in the x direction and then we will have some in the y direction. Okay, so we are going to sum all the forces in the x direction separately and then all the forces in the y direction too separately. So when I consider the forces in the x direction, some forces in the x direction, okay, so when I consider some of the forces in the x direction, I'm going to have the x component of the tension force, right? The x component of what? The tension force. And that would be what? T sine what? Theta, which is what? 30 degrees. And then this will be equal to mass times acceleration, centripetal acceleration in the x direction. Okay, so let me make it mc. Okay, so now what you are doing is that from Newton's second law of motion, we know that the net force acting on a particle is equal to what? The mass and then the acceleration of what? Of the particle. So that's why I have this equation here. So in this case, the total force acting on this particle in the x direction was what? T sine 30 degrees, and then that would be equal to what? The mass times what? The centripetal acceleration of what? Of the particle. So that's why I have this here. So rewriting this will give me T sine 30 degrees, and then this equals what? Mass times what? Centripetal acceleration, which is what? V squared over r. Okay, so this will be my equation 1. Okay, so now let's consider some of forces in the y direction. So for the sum of forces in the y direction, I'm going to have weight and then the tension. Okay, I'm going to have weight and then the tension. So the tension has the y component, which is what? T cosine of what? 30 degrees, and then the weight, which is pointing down, so that was minus weight. Okay, minus the weight, and this should be equal to what? Mass times what? Centripetal acceleration in the y-axis direction. But looking at this particle, it is said to be moving in a horizontal circle, not a vertical circle. So what that means is that there's no acceleration vertically. So that will be mass times 0, and then that will make all the right hand side to be equal to what? 0, since the particle is not accelerating vertically. So this will be my equation 2. So now I have the equation that we need to solve this question. So let's go ahead and work with the equations. Okay, so now looking at equation 1, okay, we have some of the forces in the x to be equal to T sine 30 degrees equals mv squared over r. Okay, so this is equation 1, and in the question, when you look at the question, we're given just r, we're not given the actual value of r. Okay, so when we leave it this way, then that means we are going to have some unknowns there in this equation. So for us to avoid this, let's try and then do some substitution for r. Okay, so now let's look at how we are going to do this. So looking at this figure here, okay, looking at this figure here, I can really draw something like this. Let's see, I have the long line here, then I have L here. Okay, I have L here, then I'm going to have my r here because this is the radius. Okay, r is the radius, so I'm going to have r here. Okay, so let's look at what is happening here. Let's see, if I put a dot here, okay, since r is a radius, I can trace r from the center to this part. Okay, so that will be what I have done here. Okay, that's what I have done here, and then this angle here is going to be theta. Okay, this angle here is going to be what? Theta, and then I have L here. Okay, so that's the angle theta. So let's take cosine of what? This angle here. Okay, when I take cosine of this angle here, that will be what? The adjacent side. Okay, that will be the adjacent side, which I don't know. So in that case, let's not take the cosine of what? The angle. Let's try the sine. So I'll take the sine of the angle theta, and then that will be what? Opposite. So that will be over what? Hypotenuse, which is what? L. So over L. So making r the subject, we are going to have r to be equal to what? L sine theta. Okay, you are going to have what? R to be equal to what? L sine theta. So this is what you are going to use for the substitution of what? R. Okay, so I was just trying to find some expression or some formula to represent the R here. Okay, so I just redrew a triangle from this figure that we have here to get the substitution. So that's how it's done. So now that you've gotten the formula for R, okay, we'll just go and substitute it into the equation 1. So let's go ahead and then do this. Okay, so the equation 1 now become T sine 30 degrees equals what? mv squared over what? R, which is known as what? L sine what? Theta. It is L sine theta because we know the value of L and then we know the value of what? Theta. So we can put it in this equation to reduce the unknowns. Okay, so let's continue. So this will be what? T sine 30 degrees equals mv squared over what? L sine what? 30 degrees. So this is what we have now. Okay, so we know L2 to be 1. Okay, L is given to be what? 1 meters in the question. So we can just come and write this here as what? 1 times what? Sine 30 degrees, and that will be what? Sine 30 degrees. Okay, so this will be our equation 1 now. Okay, so that's the equation 1 that we have transformed into this equation that we have here. Okay, so now let's look at equation 2. Okay, so for equation 2 also, let me clean this. Okay, so for equation 2, that's sum of forces in the y equals T cosine of 30 degrees minus weight, which is what? Mass times acceleration due to gravity, and this is equal to what? 0. This is equation 2. Okay, so now let's look at what you are going to do here. You have two equations here. Okay, so what I'll do is that I'm going to make mass the subject. Okay, I'm going to make mass the subject. So let's look at what will happen. Okay, so now I'm going to make mass the subject from what? Equation 2. Okay, so let's look at that. So that will be T cosine of 30 degrees equals mass times acceleration due to gravity. So I divide both sides by G. Divide both sides by G. Okay, so I'm going to have this equation as, let me free up some space. So this is going to give us the mass to be equal to what? T cosine of 30 degrees over what? G. Okay, so we can do some substitution here. Okay, in this equation 1 here. So let's do this. Let's do the substitution. So from the equation 1, we have T sine 30 degrees to be equal to what? mv squared over sine 30 degrees. So the m there, we are going to substitute this new expression there. Okay, so we are going to use this in place of what? M. Okay, we are going to use this in place of what? M. So let's look at how we are going to do this. Okay, so when you are doing this from equation 1, we have T sine 30 degrees, and that's called what? mv squared over what? Sine 30 degrees. But we know m to be what? T cosine of what? 30 degrees over G. Right? So this times what? V squared over what? Sine 30 degrees. Okay, this is what you have now. So over here, we can cancel out the t. Okay, we can cancel out the t. So this t here will cancel out this t here. Okay, so from there you will see that what? We only have one unknown there, which is the v. So we can now go ahead and then solve for v. So let's do this. So over here, we're going to have sine 30 degrees equals what? Cosine of 30 degrees divided by what? Acceleration due to gravity, right? Which is what? 9.81 times v squared. Okay, let me bring this here. V squared about sine of what? 30. Okay, so now let's find the actual values of the sine 30 and then cosine of what? 30. Sine 30 will give me 0.5. So on the left hand side, I'll have 0.5 equals then cosine of 30. That'll give me 0.87. So that'll be what? 0.87 v squared. Okay, all divided by sine of 30 times 9.81. So this will be 4.91. Okay, so all you have to do is just find the value of what? V. Okay, so let's continue. Okay, so to find V, I'm going to do cross multiplication here. So that what? 0.5 times what? 4.91 equals what? 0.87 V squared. Right, so I just divide both sides by 0.87 by 0.87. So this will cancel out this. So let's see what you get on the left hand side. So 0.5 times 4.91 divided by 0.87. This will give me a value of 2.822 equals what? V squared. So you want to find V, so you just have to take square root of what? The value that you got there, 2.822. So let's take the square root and see what we get. Okay, so when you take the square root, let me write my answer at the top here. When you take the square root, okay, we are going to have V to be equal to 1.68 meters per second. So that will be the velocity that we are looking for. Okay, that will be the velocity or the speed of the particle. So this is all for this video. Thank you very much for watching.